So today we are going to code Amplify and Forward relay protocol. As we did before, we first use this command to clear the windows and clear the workspace and so on. So then let's start coding, and for the first for that we consider this model and source, destination and relay dual hop network, and source broadcast data to the destination and the relay at the same time, and source go as I mentioned before, from source some data comes to the relay and forward to the destination, as well as there is a direct link from source to destination. So let's start coding to from source to destination, source to relay. First we have to define source transmit power. I consider as PS, and I consider normalized power as 1. This is the source power, and then we need some bits, so I consider as capital N. I consider about 10 to the power 7 bits, number of bits, and then I have to define the signal to noise ratio in decibel. SNR dB equal from, let's consider, -5 to 30. SNR range, signal to noise ratio range in dB, and we have to generate the BPSK data. I consider BPSK data, so that data bits to BPSK data, BPSK modulated data. Consider this part, and first BPSK data equal rand tab src within brackets from 1 to n number, we can square brackets 0, 1, and sorry, this is a binary, not BPSK, binary data, and BPSK data equal 2 into BPSK data -1. Let's see how BPSK data. So I set up a breakpoint here. Something wrong. This must be BPSK data. So you can see +1 and -1, and this is 1, 0. It's a binary data and generated BPSK data from the binary data. So you can use breakpoints to see at any point to see the output. We are going because we are considering AWGN noise. We have to generate AWGN noise, so we have to define a function for that. AWGN noise. For that, we have to define a function noise as n, and call AWGN capital N. Then we have to end the function. Now, without it you will get an error, and n equal, I use random noise from 1 to n. Then we have to define the noise. AWGN noise from paths. There are two independent paths from source to destination and source to destination through the relay. There are two independent paths. So we consider in SR source to relay, call AWGN capital N. This means AWGN noise from source to relay, as well as there are two. I copy and paste it and rearrange. Source to relay, source to destination, so source to destination, and so relay to destination, RD from relay to destination. These are the parts of the system affect the noise, and now we are coding sending bits through different iterations for different SNR values. For that, I use for loop. That's k is the number of iterations for the different SNR values. Length SNR dB, and end the loop, for loop. So you can see we are going to code within the loop, and first we have to consider SNR k equal, I think you know how to calculate the linear SNR value from the decibel value, and for that I use SNR dB divided by 10, and this is the so I have to consider different case, and as an error, so I have to close it like this. Okay, now this is signal to noise ratio linear value. Then I have to calculate the noise power from that. Noise power for different k values, and that is SNR. We have to consider SNR also, SNR linear. So we have to divide the signal power by noise power, SNR. Okay, like this. Noise power calculation for different SNR values. So let's iterate and see. You can see it's calculating different values. These are the noise power for the 30 SNR values. 36 from -5 to 30. There are 36 values. These are the noise power for different SNR. So we calculated the noise power. Now we have to code for different path. Received signal from source to relay. So I forgot something. I have to add the relay power. So I consider half of the source power as the relay power, relay transmit power. This is the relay transmit power. So then consider the received signal from the source to relay as y source to relay. And quantity PS and into BPSK data, this one, use this, and plus noise power K into, we have to define before I use this noise power, so I take this up and this is the noise power, AWGN noise, and AWGN noise. So because this is a noise power, and I consider as in SR SD RD, because this is a power, so I have to convert into amplitude, so I use QR root amplitude source to relay as this, and the next thing, received signal from source to destination. I copy and paste this, received signal from source to destination. Source to destination, source to destination is the same as before. So from source to destination and BPSK data, and this is SD, like this. And we got the received signal from source to relay, source to destination, and I need relay to destination. And signal from relay to destination. For that, y I consider y relay to destination, and I have to forward this source to relay signal y SR and into QRT relay power plus I forward this to the destination, and noise power, this one, relay destination, this is the noise power. We just forward this to the destination, and at this time we consider the source to destination link is far away, that's why we use a relay. So we need some power loss factor, so I use some 0.4 multiplication the source to destination link, because we don't use amplification, because this is just forward it. So we need some because we have to fade the source and destination link, because that's why we use a relay in between the source and destination. We consider the source and destination link is very weak, so then I combine both signal at the destination, combine both signal at destination. So YYD equal, this is YRD and YSD, direct link. And I am going to decode the signal. Decoding the signal, I use 0 post decoding. And data capital D equal here. So there are different ways you can use. YD greater than 0. If it is greater than 0, consider it as 1. So I am going to calculate the bit error rate now. Calculate the bit error rate. To calculate the bit error rate, I need what are the number of bits has error bits. Error B for each SNR iteration. S we did before, binary data minus received data D, and I have to find the number of non-zero bits and size of the vector and get the second number. What are the number of error bits? Column bit. So as you can see, for an example, I consider some matrix, row matrix as x, and you can see I print the x, size of the x as 1 4, 1 row 4 columns, and when I consider the x and the second dimension, it says 4. That means it has 4 columns. That's why what I did here, the same. And then I am going to get the error bits. By number of bits divided by number of bits. This is the bit error rate for each iteration, and I end the loop for loop, and I am going to print the amplify and forward bit error rate. Semilog y SNR in decibel, comma bit error rate, and in red color stars plus marks, and legends PER for AF for title PER for AF photo for in AWGN channel. And next label SNR dB y label that is bit rate, and wait on, and let's simulate something. Error 31, not this one, this one, single quote. Printing, I put a semicolon. It takes some time. And this is the bit error rate. I put to 30. It's let's divide into 8 and 4. And this is the bit rate for Amplify and Forward protocol in AWGN channel. And I think you can understand and just try to code yourself and get experience. And thank you for watching this video.